Let's learn about the octet rule. At the end of this lesson, students should be able to state the octet rule and describe how atoms obtain the octet configuration. Students, let's watch this video.
The octet rule is a very general rule that allows us to predict how atoms will form chemical bonds to make molecules. It's used extensively in drawing Lewis structures. When elements have 8 electrons in their outer shell, they have an octet. The octet rule is based on observations of how atoms behave in the real world. It's a general rule, and there are numerous exceptions, but it works very well for some of the most common elements that we deal with in science. So how does the octet rule work? Let's look at hydrogen and chlorine and see how they bond to form HCl, hydrochloric acid. Since both are nonmetals, they share electrons and form a covalent bond. Chlorine has 7 valence electrons in its highest energy level, sometimes called the outer shell. To obtain an octet, it needs an additional electron. Hydrogen has 1 valence electron. Hydrogen is an important exception to the octet rule. Hydrogen only needs 2 valence electrons to have a full outer shell. Instead of an octet, think of it as a duet. A covalent bond is formed when the hydrogen comes together with the chlorine and forms a chemical bond by sharing valence electrons. The hydrogen, which only had 1, by sharing now has 2. And you remember that hydrogen only needs 2 to fill its highest energy level. The chlorine had 7, but by sharing with the hydrogen, it now has 8. That's a full outer shell for chlorine, and it's called an octet. But what if we had 2 hydrogen atoms bonding? For hydrogen, which only needs 2 valence electrons to have a full outer shell, the hydrogen would join with another hydrogen to form a chemical bond, and now both hydrogens would have 2 valence electrons in their highest energy level. If we had 2 chlorine atoms coming together, they have 7 in their outer shell right now, they come together and they form a chemical bond there. They now both have 8 in their outer shell, an octet, by sharing valence electrons. Back to our HCl molecule, hydrogen and chlorine normally exist as H2 and Cl2 in the real world. So this is a bit of an oversimplification, but it's how we think about the bond between the H and the Cl forming to make HCl. To recap, the octet rule works well for many of the molecules we use in science, especially biology. But be careful, hydrogen only needs 2 to have a full outer shell. For ionic compounds, it's a little bit different. Here we have a sodium and a chlorine atom. The sodium's a metal and the chlorine's a nonmetal. That means it's going to be an ionic compound. Ionic compounds don't share valence electrons. They transfer them. So in this case, the sodium is going to lose its valence electron to the chlorine. The chlorine had 7, now it has 8, an octet. Now when we look at the sodium, it doesn't have anything in that outer shell. In fact, that outer shell goes away. And underneath it are 8 valence electrons in that new outer shell. So it has an octet. The sodium, it lost an electron. It lost a negative charge. It's going to be positive. The chlorine gained an electron, and electrons are negative. Therefore, the chlorine is going to have a negative charge. And because of that, these 2 atoms are going to be attracted to each other, and that is how the chemical bond forms in an ionic compound. Often we'll put brackets around the chlorine and a negative sign and then a positive sign on the sodium to show that they're attracted and they have formed this ionic bond. A word of caution, NaCl is considered a formula unit of a larger crystalline structure. It doesn't really exist by itself, but the idea of the octet rule still holds in this lattice structure. When we draw Lewis structures to describe the arrangement of atoms and molecules, the octet rule is a very useful guide. But just remember, it's only a guide. There are many exceptions, like hydrogen, and it doesn't always work for all elements. An octet isn't the only reason atoms bond. Electrostatic attraction between atoms is important to consider, as well as the energy changes involved when the bonds form. But the octet rule is a useful guide in predicting how atoms bond, and it mostly matches how the main group elements form chemical bonds in the real world. Finally, atoms form bonds to minimize energy and become more stable. That's a core idea that helps explain why the octet rule works for so many elements. This is Dr. B, and thanks for watching.
Students, what you got from this video? Yes, this video tells you about the Octet Rule based on Bohr's atomic model. Do you still remember about this lesson? Of course you remember it, because you already learned this lesson in secondary school. Now let me explain more about the Octet Rule. All noble gas atoms have 8 valence electrons except helium atom and has 2 electrons. The noble gas atoms do not need to bond with other atoms since they are stable and unreactive. Atoms of other elements combine with one another or other atoms during chemical reactions. Maximum stability is achieved when a noble gas which having either a duplet or octet valence electrons. Octet rule states that the atoms tend to attain stability either by losing, gaining, or sharing electrons so as to have a filled valence shell of 8 electrons. The rule works mainly for elements in period 2. Let me explain about the octet rule based on quantum mechanical model, achieving octet by transferring of electrons. Here we have sodium. Its electronic configuration is 1s2, 2s2, 2p6, 3s1. Sodium has 1 valence electron. And we have fluorine. Its electronic configuration is 1s2, 2s2, 2p5. Fluorine has 7 valence electrons. Sodium is a metal and losing its valence electron when donating the electrons to fluorine atom, while fluorine is a nonmetal. Fluorine gained that electron. Sodium atom turn to positively charged ion Na+. Its electronic configuration is 1s2, 2s2, 2p6. 3s orbital goes away, but leave new outer shell containing 8 electrons. Na+ has octet. Fluorine atom turn to negatively charged ion, F-. Its electronic configuration is 1s2, 2s2, 2p6. After gain 1 electron, fluoride ion becomes octet. Both sodium ion and fluoride ion have completed octet. Achieving octet by sharing of electrons. We have 2 fluorine atoms coming together. They have 7 valence electrons in outer shell. When become together in form of chemical bond, both fluorine have 8 electrons in the outer shell. Now both fluorine have completed octet. Let's test your knowledge. Which of the following bonding patterns does obey the octet rule? Let's count the bond around X. Every one single bond represents 2 bonding electrons. Double bond represents 4 bonding electrons. And triple bond represents 6 bonding electrons. In A, X has 2 single bond and 1 double bond. It means X surrounded by 8 electrons. Therefore, X obeys octet rule. In B, X has one triple bond and one lone pair. That means X surrounded by 8 electrons. Therefore, X obeys octet rule. In C, X has 3 single bonds. It means X surrounded by 6 electrons. Therefore, X does not obey octet rule. In D, X has 4 lone pairs. It means X surrounded by 8 electrons. Therefore, X obeys octet rule.